Structural racism is the use of laws, practices, and infrastructure to disadvantage Black Americans post-emancipation from slavery in the late 1800s and early 1900s. Some structural racism tactics used that are widely known are Jim Crow laws, hiring discrimination, and redlining. Redlining is a practice made by the Home Owners Loan Corporation, or HOLC, during the first Great Migration of Black people from the South. These redlining laws only allowed Black people to get housing in certain graded areas. Areas and towns were graded A through D on maps and colored in green, blue, red, or yellow to match the grade. Black people could only get home loans in areas with red, yellow, or C and D grades. These C and D graded areas were known to have higher risk of environmental hazards, water pollution, air pollution, and noise pollution, causing a disadvantage for Black Americans in the early 1900s. My research aimed to find if there was still a correlation between redlining and drinking water contamination using data that was already provided by the U.S. Census Bureau, Open Data Maps, as well as the University of Richmond's HOLC map digitizing practices. For my research, I used a multi-step analysis and a mixed methods review inspired by Evan Elderbrock's approach of urban green space use in Portland, Oregon. This methods paper used demographic data as well as mapping information and zoning information to create a research project that would create a visual for what he was attempting to research. I decided to go a similar route and use something like Evan Elderbrock's methods paper. For my research, I used 10 cities in the United States with populations of 600,000 or more and got demographic information from the U.S. Census Bureau, parsed through it to get race by population, renting versus owning status, as well as race by income in each city. This information was used to prove that there is still a racial bias or racial gap in each city to first confirm that there is discrimination still occurring. The second step I used the University of Richmond's website that digitizes these maps of redlining, and I used them and overlaid them on top of a map on ArcGIS Pro I made, as you can see to the left. The maps I made included industrial zoning information from each city, pipe material information or city line information, and watershed information on top of the redlining map, as well as population information from the U.S. Census Bureau. Each dot on the map to the left represents 2,000 people of a certain race, and this is all from the U.S. Census Bureau website in 2020. For the first step of identifying a gap between races, I found one in each of the 10 cities that I chose. The example I have on this poster is Jackson, Mississippi. The pie chart to the bottom right is the race by population of Jackson, Mississippi. The yellow piece of the pie represents Black people, and the red represents white people. As you can see, Black people make up over 75% of the population in Jackson, Mississippi. But on the left pie chart, you can see that white people still make 50% of the median income. And the graph under that, the 3D bar chart, shows that white people rent less than Black people do. Renting data is in blue, and owning data is in orange. Each chart in the middle that has no information means that there is not enough people of that race in said city to be able to tell if there's a big difference in renting versus owning. Since a racial bias was proved in this city, I then went on to analyze the zoning information for each area on my interactive map. So if you were to go to my map and click on each color polygon, you would see the zoning information pop up, meaning you would see something that says industrial, commercial, residential, and so on. And I found that in each of my cities, most of the industrial areas were found in these red and yellow zones. And this also happened to be where a lot of the Black and Hispanic population tended to live, especially in Los Angeles, San Francisco, and Portland, Oregon. This shows that the environmental hazard risk is a lot higher for these areas as late in time as 2020, showing that there still is some kind of correlation between redlining and drinking water quality. I could not find any pipe or water information because of the Safe Water Drinking Act implemented in the 1970s being halted by an executive order in January of 2024. I did have information on pipe material such as like copper, aluminum, and lead last year when I began my research project. But because I am using this on a public Esri ArcGIS site, that information has been taken down from by the US government, and I am yet to find it again. But we do know, and a lot of research has shown, that airports, freeways, and factories and other things that are in industrial and commercial zones are tending to have a lot of environmental runoff, leading to poor water quality. For example, Flint, Michigan is a town in Michigan that has a high population of Black individuals. Their watershed is Lake Flint as opposed to Lake Michigan, and Ford Motor Companies dumps their waste into Lake Flint and pulls clean water from Lake Michigan. So all of the PFAs or forever chemicals, lead, and other harmful contaminants are getting into the water that Flint, Michigan uses, and that is still a big issue today. I have found other correlations with this in the other 10 cities that I have decided to look at, including Detroit, Jacksonville, Florida, Jackson, Mississippi, and Portland, Oregon. So, using my multi step and mixed methods analysis, I did find that there is still a troubling relationship between redlining and water contamination. In the future, I hope that water data and water contaminant data will come back to the internet or to an open public forum so that I continue to work on my mapping and other information. I would like to thank the University of Oregon. I would like to thank the McNair program, and I would like to thank Dr. Corey Russell for helping me with this research.